In this question, we're given another circle diagram, and we have to find the value of the missing angle, or angle x right here. So before we begin this, I want to call this point A, this point B, and this point C. Now, in order to solve this, we're going to need to know a couple of different properties. We'll need to know the properties of an inscribed angle, and we'll need to know how that inscribed angle relates to a central angle. And we'll also need to be aware of the properties of an isosceles triangle. So to begin here, we're given a measure of 40 degrees on here. Now, from point A to O, we can see we've got a radius. And from B to O, we've also got another radius. So, we know this side is equal to this side, which makes triangle AOB isosceles. Now, the base angles of all isosceles triangles are equal. So that allows me to put 40 degrees here for angle B, because we have 40 degrees for angle A. Now, within any triangle, we have 180 degrees, which all angles must add up to B. So I have 40 degrees for A, 40 degrees for B. I've used 80 of that. That leaves me with 100 degrees left here for angle O, which is a central angle. Now, to find angle X, what we can see is that we've got angle ACB is an inscribed angle, which is subtended by this arc here from A to B. And angle AOB is a central angle, which again is subtended by that same arc. In other words, the legs that shoot off of these end up at the same spot on the outside of the circle. They both end up at points A and B. And if that's the case, we know that angle X has to be half the measure of the central angle, which is angle AOB. Now, since we know angle AOB is 100 degrees, we can input that here and take half of it to get a measure of 50 degrees for X, which is B.